Hello there, my name is Gary Sims from Android Authority. Now, two of the most popular mobile processor design companies at the moment are Qualcomm and Apple. Now, Qualcomm's current leading processor is the Snapdragon 821 and Apple's, of course, is the A10 Fusion. But how do they compare with each other? What are they like when you put them side by side? Well, if you're brave enough, follow me and let's find out. Now, before we get started with this comparison, I just want to say two things. First of all, we are just talking about chips inside of a mobile phone. There's enough problems in this world. There's wars, there's diseases, there's terrorism. Okay, let's not just blow this out of proportion. And the second thing I'd like to say is that actually Apple and Qualcomm aren't too forthcoming about the technology that's in their mobile processors. So we have the Snapdragon 821 and we have the Apple A10 Fusion. Well, what are they like when you put them side by side? What are their feature lists? Well, let's have a look. Well, first off, it's worth mentioning that both chips are quad-core ARM v8 compatible processors. Now, Qualcomm and Apple both have architectural licenses from ARM, and that basically means they have the right to design their own ARM compatible chips using their own designers, using their own technology, as long as it is compatible with ARM's instruction set and architecture. Now, they've both got quad cores and they both use what's called heterogeneous multiprocessing. That's why Apple are calling Fusion. What it basically means is that two cores are kind of high performance, they run at a higher clock speed and they use more power, and there are two cores which use less power, run at a lower clock speed and are more power efficient. And the idea is that they juggle between the two depending on the different workload. However, there is one big difference. Qualcomm can use all four cores simultaneously. However, from what we understand, the Apple chip can actually only use two cores at one time, and it switches between the two powerful cores and the two less powerful cores. Now, in terms of the GPU, we have the Adreno 530 in the Qualcomm 821, and that's Qualcomm's greatest and latest GPU, and Qualcomm have been designing GPUs for several years now, and we find them in their different series of chips as we've been going over the years. Now, up until now, Apple has used the Power VR GPU from Imagination Technologies. However, this is the first time that Apple are actually shipping their own GPU. Now, talking of GPUs, it's also interesting to note that Apple supports OpenGLES 3.0 and its own Metal API, whereas the Qualcomm Snapdragon supports OpenGLES 3.2 and the Vulkan API and various other APIs. So Apple have got less API support, but then again, they control the whole phone. These chips are only meant to go inside of iPhones and maybe inside of iPads, whereas Qualcomm sell their chips to just about everybody that will buy them, including Samsung, including other smartphone makers, including set-top box makers, including tablet makers, including media player makers. They have produced a general chip that will cater for lots and lots of different use cases, whereas Apple are producing one that only supports their use case. And of course, that's a difference in the business model between these two companies. And one last thing worth mentioning, the Qualcomm Snapdragon 821 actually has Quick Charge 3.0 support built into the processor. So every phone that has the 821 in it is capable of having quick charge technology built into the phone, every tablet the same, whereas Apple at the moment doesn't have any quick charge technology, and it's certainly not found inside of the SoC. And in fact, talking of things not included in the SoC, another thing that's interesting is that the Qualcomm chip includes the LTE modem, that's the modem used by your 4G and 3G and 2G networks, built into the SoC, whereas Apple don't build the modem into their SoC. The A10 doesn't have a modem built into it, but it does use modems on external chips. And interestingly enough, 3 out of 4 Apple phones use Qualcomm modems. So Qualcomm actually are being used inside of Apple chips for their modem technology. Now, my testing for performance comes in two categories. First of all, I'm using several of the off-the-shelf benchmark apps that you can find that work on both iOS and on Android. So for example, we've got Antutu, we've got Geekbench, and we've got Basemark OS 2. Now, my second set of benchmarks are ones that I've written myself. Now, writing benchmarks that work across two platforms is quite of a challenge. So the first set of benchmarks I use the Lua programming language because there are SDKs available for both Android and iOS. And then I've actually got some C programs that I wrote, and I've used those in a previous video that I've done when I was comparing the difference between C speed and Java speed on Android. And I've taken the same code and I've compiled it on Android and I've compiled it on iOS to see what the difference performance is. So let's go and have a look. Now, to do these performance tests, I've got a Google Pixel smartphone and I've got an iPhone 7. Now, as a caveat, of course, there may be faster Snapdragon 821 devices out there. I've chosen the Pixel because it's probably one of the most important phones of this year. And of course, I know that there is a difference maybe between the iPhone 7 and the iPhone 7 Plus. For example, the iPhone 7 Plus has got a bigger screen, it's got a greater resolution screen, so the GPU will have to work harder. So, I know these are just two phones and maybe we could use different phones to get different results. However, those are the two that I've got, and they do give us a good indication of the underlying performance of the SoCs. So our first test is with Antutu, and as we can see, the iPhone 7 beats the Pixel, not by a huge amount, but by a significant amount. Now, if you go over to the AndroidAuthority.com website and find the article that goes along with this video, you'll see how I've analysed the individual figures that come from the Antutu results to see how it got these particular numbers. And in particular, it's worth noting that according to Antutu, the Pixel has a better GPU than the iPhone 7. However, for the rest of the test, the iPhone 7 is actually faster. And now our next test, of course, is Geekbench, and Geekbench has two types of tests. One is a single core test, which basically runs on one core in the phone. So it doesn't matter if there are 2 cores or 4 cores or 8 cores, it will give you the same result because it's a per core test. And we can see that the Apple A10 Fusion is significantly faster than the Snapdragon 821 when it comes to the single core test. And in the multi-core test, basically all 4 cores are used simultaneously. And again, we can see that even in that multi-core test, the iPhone 7 came out tops. And then really to verify that Antutu and Geekbench are telling us the truth, we'll use Basemark OS 2 here, which again shows a fairly significant win for the Apple A10 Fusion. Hats off to Apple, that's an excellent result, and definitely the numbers speak for themselves. That was the results that we've got from these popular benchmark apps, but now I'd like to use my own benchmarks to see what numbers we get out. Now, my first test basically does a whole bunch of math processing, it does some prime number finding, it does some hashes, it does some table sorting, and basically it runs through the test and it tells you how long it takes for each test to run. Now, the time is in milliseconds, and we can see that actually the Apple produced its results, managed to get through all that test in about half the time of the Snapdragon 821. So according to my first benchmark, the other benchmarks by Antutu and Geekbench seem to be coming true. The A10 certainly did very well during this test. Now, for my second test, I move things over slightly into the graphics world. I have a simulation which kind of puts 2 drops of water every frame into a container, uses a physics engine to run that, all that calculations. There's some floating crates that float around in the water. There's more water being added in, and basically it counts to see how many droplets of water can go in a 90-second period. Now, the theoretical maximum score is 10,800. So let's have a see how these two phones did. Well, the scores are almost identical. The Apple A10 Fusion in the iPhone 7 managed 10,202 droplets of water in a 90-second time frame, and the Snapdragon 821 with the Google Pixel managed 10,178. So they're almost even. So it seems that as I bumped up the complexity here to the whole 2D physical simulation with all those particles of water going around, that actually both phones performed very, very well. And for my third set of tests, we're now using the C programs that I wrote both on iOS and on Android. And there are 3 different tests. The first one produces some SHA1 hashes for a block of data, does that lots and lots of times and then sees how long it takes. The second one tries to calculate the first million prime numbers using trial by division. And the third one is basically just a complicated maths function that does multiplies and divides, does floating point operations to see which function, how long it takes to run that function. So let's have a look at the results. Now, in this particular case, lower is better, and the Snapdragon 821 managed to complete my test in 0.654 seconds compared to 0.864 seconds for the iPhone 7. We see the same thing again with the prime numbers, half the speed half the time taken on the Snapdragon, twice as long taken on the iPhone 7, and again for the maths function, again the same thing, 0.15 seconds compared to 0.303 seconds. Now, this is a bit of a mystery because up until now, all the benchmarks we've seen have told us that the Apple A10 is significantly faster than the Snapdragon 821 in the Google Pixel. And yet when I run these C tests, we find that actually it is the Snapdragon 821 which is twice as fast as the Apple A10. Now, I don't know why that is. I just know that I compiled these two C programs on the respective development tools that you have for each platform. Now, there could be some problems. For example, maybe the optimization inside of the iOS app is less than the optimization on Android. That's a possibility. Maybe the tests were too short. For example, maybe the test ran on the lower cores in the iPhone and the scheduler didn't have a chance to swip them over to the high power cores because they only last, as you've seen, half a second or something like that. So maybe the scheduler didn't get round to moving them over to the high power cores, or maybe there's some other kind of optimization that goes on in the software level that tells the hardware to do things differently, and that didn't kick in when I was running my tests. So I don't know why, but according to these tests of mine, the Snapdragon 821 is significantly faster than the A10. Now, without further research, I really can't say any more than that. So it's all very well having the performance, but what about the power? How is the power usage of these two different mobile processors? Well, as I've said, I'm using the Pixel and I'm using the iPhone. Now, they've basically got different battery sizes in them. There's different screen sizes. In fact, the Pixel has twice the resolution in terms of pixels than the iPhone 7, so there's more power being used by the display. So this is quite difficult to actually do. So what I did, and this is really the best I could do right now, is I turned both phones on, turned them down to their minimum brightness level and left them for an hour sitting on the home screen of the respective operating systems and just saw how much battery was used. And then when I ran the tests, I actually subtracted that power usage from when it was idle, hoping that that will take away what the screen used, so we can get maybe a closer look at what the system on a chip is using. So then what I did was I ran two tests. One is I used the 3D game Epic Citadel to test the 3D capabilities of these two processors, and then on the second test I played a video to see what the usage was like. So according to my calculations, for doing the 3D gaming, the Pixel used 415 milliamp hours worth of battery, whereas the iPhone 7 used 319 milliamp hours of battery. So it might seem at first glance that the iPhone 7 is more power efficient than the Google Pixel. However, we have to remember that the Google Pixel is pushing around twice as many pixels per frame when it's running Epic Citadel. And it's actually doing that without using twice as much power. So although the Pixel is using more power, it's actually doing more work. And for the second test running the video, we find that actually both devices use basically the same amount of power. So even though the Pixel is powering a higher resolution display, the video processors in both phones work very, very well. And so now this year, there's going to be millions of phones that will use the Snapdragon 821 and the Apple A10 Fusion. I won't declare which is best because clearly in terms of performance, the A10 seems to have the lead, but there are other factors involved like cost, for example, like API support, like modem support, like fast charging that you find inside of the Snapdragon 821. What's the GPU like in the 821 compared to the GPU like in the A10? I'll let the numbers speak for themselves. You decide which one you prefer. Now, I really will look forward to reading your comments, but can I just again ask for a level of maturity? We're talking about chips in a mobile phone. We're not talking about anything else. The world has got enough problems as it is without people getting angry with each other about which mobile phone they use. So if you want to talk about the technology, if you want to admire what Qualcomm and Apple have both made, then let's just talk about it in the comments below. Well, my name's Gary Sims from Android Authority. I hope you enjoyed this video. If you did, please do give it a thumbs up. Also, don't forget to subscribe to Android Authority's YouTube channel. Don't forget to download our Android Authority app because that will give you all of our latest news directly on your mobile phone. And of course, last but not least, don't forget to go to androidauthority.com because we are your source for all things Android.